This is a video on lamination, a special form of catenation in APL. This is not a video on catenation itself. If you want to know about catenate, have a look at this video here. Lamination occurs when two arrays of a same given rank are combined to form an array of higher rank. Lamination for vectors can occur in two ways. Horizontally, we get a 2 by n, two rows of n elements, or it can occur vertically. In this case, we get a two-column matrix. Here is an example. We have two vectors of rank 1 that can be combined to form a two-column or a two-row matrix. So here's V1 and V2. Lamination is a special function in APL. It is a derived function, just like a summation which uses a plus slash. It uses an operator, the bracket axis operator. Here V1 will be laminated to V2 by introducing a new dimension just before rank 1. So 0.5 is before 1, so we get a 2 by, in this case, 10. Any number between 0 and 1 would have worked. This is similar to mix, using the monadic up arrow. Scalar extension works too. The scalar is repeated. But this is different from mix, because mix pads with the prototype. Likewise, we can create a matrix of two columns by specifying a number between 1 and 2. It works for any data type too. Here we underscore a character string. So if we use a number between 0 and 1, we add a dimension to the left. And if we use a number between 1 and 2, we add a dimension to the right. Lamination works for higher rank arrays too. For matrices, it can occur three ways. On the first dimension, we get a 2 by whatever rows and columns we had before. Two planes. We can laminate on the second dimension. In this case, we introduce a new dimension between the rows and the columns. We get R planes of 2 by whatever number of columns we had. And it can occur on the third dimension. In this case, we're going to end up with a two-column, three-dimensional array. So if we have two matrices of 3 by 4, if we laminate with a number between 0 and 1, we get a 2 by 3 by 4. If we laminate with a number between 1 and 2, we get a 3 by 2 by 4. And if we laminate with a number between 2 and 3, we get a 3 by 4 by 2. So again, if the number is between 0 and 1, we add a dimension to the left. If we use a number between 1 and 2, we add a dimension in the middle. And if we use a number between 2 and 3, we add a dimension to the right. Note that like most bracket axis operator derived functions, this one is subject to quad IO. So if your quad IO is 0, you need to account for that. So in this case here, we will need to use a number between -1 and 0 to add a dimension to the left. If we use a number between 0 and 1, we will add a dimension to the right. And if we use a number between 1 and 2, we get a rank error.